Okay, here we are for the 6th week of CS204. We are recording this video after 3 years because it was missing. So let's start with today's example. Today we're going to see new topics, like we're going to see copy constructors. Yes, you have seen copy constructors before, but this time we'll see new topics related to copy constructors, like shallow copies and deep copies. Also, we're going to see operators, namely with, let's say, integers or doubles. We have operators like plus, addition, subtraction, multiplication, division, etc. We can do and we can define similar operators and operations for other data structures like maybe queues, stacks, linked lists, etc. And we do it according to our wills. So, in order to do this stuff, we are going to see those topics, namely deep and shallow copy constructors, as well as operators. With queues, yeah, we saw queues last week, but we are going to add some extra stuff. So we're going to see some repetitions, and we are going to see the new topics for today. Okay, so what is queue? Again, queue is a data structures from which works in first come, first serve fashion, meaning that if a customer or data or whatever comes, it always goes in the end. We call the end the rear. And if you are going to take some data, we always take it from the beginning. So this is my front, or the beginning of the queue, and this is my rear. We always put new data from the rear, and we take it from the front. This is the queue, as we saw it during last week. Okay, so we have the same class basically, but expanded with some new stuff. So let's go and see our class. Before that, let's see our queue nodes. We have a string, so our queue nodes looks something like this. So we have a value, variable called value, which is string. We put our information here. Then we have a pointer, which is a pointer to the next queue node. So it's a pointer to the queue node. The name is next. Here we have our parametric constructor, which basically we take a string and a pointer. Its default value of the pointer is null, and we set the value to be the string and the pointer, and this next pointer to be ptr. If we don't give any value, by default it's null. As simple as that. Now let's go and see our DynamicStringQueue class. So we have class DynamicStringQueue. Okay, let's see what do we have here. Private data, private variables. We have the front. So in our data structure, we just keep the pointers to the front and the rear of those nodes, of this queue basically. So front points to the first element that we should take, and rear is a pointer that points to the last element that entered the queue, the last node that entered the queue. And when we add from the rear, and when we take from front. So this is my private data. Public, what do we have? By default, we have the constructor. So I'm going just to write it as an abbreviation: DynamicStringQueue, dynamic strq. So this is my default constructor. Then we have the destructor, which is the function that we call when we destroy an object of this class. I mean, it's destructor because of the tilde, and the name of the function is the same, but we have the tilde in the beginning. Then we have a copy constructor, which is our new topic for today. So we have DynamicStringQueue. But this is copy constructor, and we'll see some topics about the copy constructor. Remember, we take it usually as a constant reference. Enqueue is the function by which we add an element into the queue, and it takes a string. Basically, we have the string over there. Okay, never mind that. Dequeue is to take an element from the front. So enqueue puts in the rear, dequeue takes from the front. And pay attention, we have here a reference. So the value that we are going to dequeue here will be put in this reference, in this parameter. Okay, then we have the function isEmpty and clear. So isEmpty, it returns true if the queue is empty, otherwise it returns false. Clear is to delete all of the elements of the queue. So this is clear. Then we have get front, get rear to get the front and rear pointers. I'm going to write them get front, get rear. Then createClone, where I can write it. Maybe I can write it. Okay, so all of these are public. So I can write createClone maybe here. createClone. We use this one to create another clone of the same queue. Operator equal and operator smaller than. So operator equal and operator smaller than. So basically, we are going to use with queues those two operators, equal and small. Then we are going to define what do we mean by them. Okay, we've seen with integers something like c is equal to a plus b, and we know what does it mean. What do we mean by this in q? So what do we mean if I say q1 is smaller than, I don't know, it's taken an integer as a parameter, is smaller than 3. What do we mean by this? We are going to define it in our function. Okay, so this is my class, the declaration of my class and the functions inside, member functions. Now let's see their definitions. Let's go firstly with the constructor, which is the first function that we call when we declare a variable, an object of the class DynamicStringQueue. So, let's go with this guy, constructor. Basically what we do here is the following. We just set the front and the rear be null, meaning that we don't have any element. We just create a new queue. So front is null, and my rear is also null. This is it. Now let's go with the function, which one? isEmpty. isEmpty. Let me find it. Basically checks whether queue is empty or not. It checks whether the front is null. If the front is null, that means that there's nothing to take off from the queue. So if the front is null, we return true. Otherwise, we return false. Because if there's a note, that means we can take it. Otherwise, we cannot take it. So it's as simple as that. Now let's see the function enqueue. This one. This is used to add elements to the queue. Let's add a few elements and see how it works. So enqueue is here. It takes a string as a parameter, which is the element, the value field of the node, and it checks if the queue is empty. You see, those are member functions, public, okay, but those can access the private data because they're inside of the class. It's not a problem to do that. Other people cannot. Everyone outside from this class cannot access the private data. We know it. So if the queue is empty, what do we do? Is the following. Front is equal to queue, new queue node element. So basically we're calling the constructor of the queue node class. And this is what we do. Firstly, we go with the right side of the equality. We create a new node calling the constructor that I explained. It takes two parameters actually, if you remember. Queue node takes two parameters, which were the string and the pointer. If I don't give any value for the pointer, by default it's going to be null. So we put the element, let's say the value of the element is CS, only CS. So I have here CS in the field. and it's pointing to null. And the new comment always returns the address of the node that I just created, and it assigns it to front. So front is equal to the newly created node. Of course, this is the only element in the queue. Rear is also pointing to it. So rear is also pointing to this guy. Now let's assume we are calling again the function enqueue, and it's not empty, so we call the queue with an element. Let's say the value of this guy is 204. So is it empty? If you remember, empty returns true, the queue is empty, otherwise it returns false. It's not empty because the front pointer now is pointing to a node, which is not null. So we go to the else part, and we say rear next is equal to new queue node. So basically we create a new queue node. The value of that guy might be, let's say it's 204. The element value ELMT is 204. Since we didn't pass any argument for the pointer, automatically by default it's null. And then the new comment is returning the address of this node, and we assign that address to rear next. So this is my rear. Rear next is equal to this node. So this is how we add elements into the queue. Again, if we call it again, we might add another element. Let's say it's course over here, etc. And finally, in the end, always we say that it's rear. So that's not complicated things. So rear initially was here, right? And when I created this node, it was pointing to null. So now I'm saying rear is equal to rear next, because the last element now is the newly created one. So rear is pointing to next. In the same fashion, if I call the function again, let's say with the value course, it's pointing to null. Rear is going to point, rear next is pointing to this one, and rear is equal to rear next. This is it. Okay. So this is the function enqueue. Now let's see what the queue is doing. Remember, when we enqueue a node, we do it dynamically. So front and rear are in our program stack, but those guys are at the heap. Those are dynamically created. Now, when we are going to dequeue them, that means we are going to take an element from the front now, we are going to delete the node that we are going to take. So let's see the dequeue function. We have a pointer to queue node which is 10. If it's empty, of course, we say attempting to queue an empty queue, and we exit the program. Otherwise, if the queue is not empty, remember that the dequeue function as a parameter takes reference to string. Basically, when we are going to dequeue an element from the queue, we are going to put it to this guy. It's kind of a return value. So if it's empty, we're not going to do anything. If it's not empty, then we just say that this element over here, the reference is equal to front value. So we have the element, ELMT. This is my element, ELMT. And it's equal to only this node, this part. Maybe I should write it with another color. So this is my element. Only this node. Only the info value, which is the value of this guy of the node. So this is my element. Then I'm saying temp, which I defined in the beginning, is equal to front. So temp is pointing to front. Then I'm saying front is equal to front next. Front goes to the next element because we're going to delete it now. So front is equal to front next. And I'm deleting temp. But when I delete temp, I don't delete the info value, the string that I had inside, because it's now referred by this ELMT. So I'm deleting only, if you want, the boundaries of this node. Okay? An element is a string, and the value of that string is CS. Otherwise, everything else is deleted to the node. Of course, when the function is finished, we don't have the temp value, so we can access now CS through the reference that we took as a parameter. Okay, so this was enqueue. Now let's see the function clone. This was dequeue, I'm sorry. Now let's see the function clone, createClone. Let me do it with thread. I'm going to check it, so we're doing with that function. By the way, we have two easy functions, which are getFront and getRear. Front just returns the front, and rear returns the rear. So getFront returns the front, which is pointed to queue node. The same applies to rear. So let me check them also. GetFront and getRear. Now let's see the function createClone, and then we'll go with the copy constructors. We'll see why. Because as you see, copy constructors actually call the function createClone, the number function, createClone. So what do we do over here? Copy constructor means that as a parameter, always, this is the case always with copy constructors, we take, usually, not usually, it should be like that, a constant reference to an object of the same class. And we want to make an exact copy of that to ourselves. So how do we do that? Well, it's very, and this is, so a constructor, basically, in terms of integer, if I say something like this, integer c and 5, this 5 is an integer, and c is also integer, and I'm making c be equal to 5. Okay? This is done when I'm creating or declaring a variable of the same class, the same class. And as a parameter, I'm taking an object which is already created of the same class. So, let's assume that this is my new class, my new object that I'm trying to create. The value of the object, so initially it shouldn't have anything. Of course, we have the rear and the front functions. And this is my copy. So this is another object. Maybe I should draw it with another color, so not to confuse them. So this is another object of the same class. So we have here front, we have here rear. And let's assume that those are the data that we have for this one, like 1 as strings, of course. This is the queue that the copy has, 1, 2, and 3. So rear is pointing to the last element. Okay, so this is my copy. Let me write it here. It's my copy that I'm taking as parameter here. Okay, it's already created, and I want the newly created object to be the same, the exact copy of this one. Okay? Now, there are two ways how I can do it. I can do it with shallow copy, or I can do it with deep copy. What is the difference between them? If I'm making a shallow copy of that, I'll show you the code, but let me tell you the idea of what we are dealing. I can do simply something like this. So we have those nodes, and I can make front to point over here of the newly, so this is a new object that I'm creating, and I can make rear to point to the rear of the copy. This is it. This is shallow copy constructor. However, do you see any problem over here? What if copy changes the queue? It might add some elements, or it might delete some elements. What we are going to see? So let's say this copy that I want to clone myself and be like this guy. If this guy is going to delete this dequeue, this element, so it's going to point basically, as we saw it, to the next element. So now front is pointing where? Nowhere, right? And it's a mistake. Okay, that's why usually we don't want to make shallow copies. Otherwise it's very easy. I just say front is equal to copy front, and rear is equal to copy rear. Okay, but what I want to do, I want to have those guys that I have in the beginning, 1, 2, 3, make a copy of them and have 1, 2, 3. So the values are the same, the queue is the same, but actually there are different variables. Okay? So this is shallow copy, I just make the pointers be the same as the pointers of the copy. And we have deep copy, I just make the same queue, clone of that one, and put it over here. So let's see how do we do that. Okay, actually, so this is not the copy constructor. We are going to call the createClone in the copy constructor. This is createClone. So it's not the copy constructor, it's createClone. But it's doing the same thing. Okay, so if copy front, no, if the front of this guy is null, that means that this queue up is empty. I'm just making front and rear be null. Nothing else. Otherwise, if it's not null, the copy object, this one, if it's not null, then I'm going to make a clone of it. And I'm going to be a clone of that guy by copying all of the values of the queue one by one. So, how am I going to do that? Okay, so I'll just say temp is equal to copy front. So temp, this is my temp pointer. It's pointing to copy front. Then I'm saying front is equal to new queue node temp value now. Basically, I'm going to create a new node. The value of that one will be temp value, which is 1. Okay. It's going to point to null for now. Okay. And I'm going to assign that value to front. So this is what I'm doing. Okay. So front will be pointing over here. And I should do it like this so we can see it. So front is pointing to this one. Okay. Now, if I have still elements till the end, I'm going to take them one by one and put it from this queue, make a copy of it to myself. So from this copy or object that I want to copy to myself. Because I'm saying myself because this is a member function and it wants to clone the object that it's taking as a reference. Okay, so while temp next is not null, and we see temp next is not null, then I'm saying temp is equal to temp next. I'm going to point to this data, next pointer, and then I'm adding those from the rear. Then I'm saying, I'm sorry, I forgot to say here, to write here that the rear is equal to front. So rear is pointing right now to the front. Okay, so temp is not null, so temp is pointing right now over here. We are inside of the while loop now. We're dealing with this while loop. Okay, so rear next is equal to new node. That node is taking temp value, which is 2 as parameter, and now a pointer. And I'm saying rear next, which is rear next, is equal to that guy. Okay, so here we go. And then I'm saying rear is equal to rear next. So rear is pointing now to the last element that I added. We go in the beginning. Is temp next equal to null? No, it's not. So now temp is going to point to this node. I go inside. Temp is equal to temp next. I'm creating a new node again, which is this one. Temp value is 3. It's pointing to null. Okay. And I'm assigning the address to rear next. So rear next is the newly created node. Okay? And rear is equal to rear next. So rear is pointing now to the last node of the queue. Well, if you go now at the while loop, tab next is null, so we go outside when the function finishes. Also, data that we have are finished. And what did I do? I created a copy, a clone of this copy, and made myself, meaning if I'm, let's say, the new variable, I made myself be equal to the copy, a clone of the copy. As simple as that. Now, this was not the copy constructor, by the way, although it's very similar to it. So let's see what the copy constructor is doing. It should be down somewhere. Okay. Basically, the copy constructor is calling the clone function. Uses operator equal. Okay, so here we have a copy constructor. It takes a copy, it calls the function createClone with copy, nothing else. But in order to know what we are doing, we just write that copy constructor is invoked. We will see when we call the copy constructor. Just to remind you, so you're not going to forget. The copy constructor, remember, if you are sending a parameter by functions, if it's not a reference, you're not sending the original one. You're sending a copy of that one, right? And how do you make a copy? Calling the copy constructor. Okay. Also, when you return a value, you don't return the value exactly. You return the end of the function. You return a copy of it. And how do you make a copy of an object? Using the copy constructor. Okay. That's why we're writing here copy constructor is invoked if you are using the debug mode, so we can know in which function, member function, we are at the moment. We did the same, if you remember, with enqueue and dequeue. Okay, so at the end of the dequeue function, we just print that something is dequeued. Or if we want to enqueue, at the end of the enqueue function, we print that something is enqueued. And in the copy constructor, we're just saying the copy constructor is invoked. And copy constructor is doing nothing else but calling the createClone function. It's making a clone of the object that I'm taking as a constant reference. And the object should be of the same type as the class which is calling this copy constructor. Okay, so remember, constructors, be it default constructors, copy constructors, parametric constructors, always we call them to construct an object. Okay, and here we construct an object using the same type, the same class of the object that we are creating. Basically, we want to make a copy of it. That's why it's called copy constructor. Okay, any questions to that? No questions. Then what we are going to see next, which function? Operator equal. So let's see operator equal. Operator equal is similar as the constructors, but it's not exactly the same. And we'll see why. It also, as a parameter, takes a reference, a constant reference of DynamicStringQueue, so the same type of the same class. We are going to call it right-hand side. So what we are doing with operator equal. Let's say I have a queue. And I'm saying queue is, let me write it here. Q1 is equal to, let's say, Q only. Let's assume that we already created the queue. We have it before when, and we have created also Q1. So both of them exist in the memory. But we want to make sure that Q1 is equal to Q. Okay, so this is not a constructor because already Q1 and Q2 exist. Maybe we have defined them like dynamic string Q. Let me delete this one. And I've defined Q1 and Q. Okay, so they already exist. Okay, and by the way, since we are here, what I'm using here to create Q1 and Q2? Of course, when I create an object, I must call the constructor. Which constructor I'm using here? Can you tell me? Does it take any parameter, this one, this one? No. If they don't take a parameter, I'm using the default constructor. That means that the Q1 and Q2, which are part of the class DynamicStringQueue, have their front and rear pointing to null. Okay? But if I say something like this, so dynamic, I'm using abbreviation now, DynamicStringQueue, let's say Q3, and I'm taking Q1 as a parameter, then now I'm calling the copy constructor in order to create this one. Okay? Now I'm using the operator equal, but Q1 and Q already exist. So what the operator equal is doing is this stuff. Okay. Now, but since the operator equal is clearing, it's using the clear function, let's go and see what clear is doing, and we'll go back to to operator equal. So clear. So basically what clear is doing is just deleting those nodes one by one. If you remember when we dequeued a node, we used to delete it, so clear is basically dequeuing all of the nodes of the queue. So, and I'm taking the value, while the queue is not empty, I'm dequeuing it and putting to the value. Okay, so dequeue is deleting all of the nodes one by one. Okay, this is the function clear. I'm clearing the queue, so it's going to be empty. So where is clear? Here. We saw the function clear. Now let's see operator equal. We also saw the copy constructor. And now let's see operator equal. Okay, there's something interesting with the operator equal, something which we have not seen up until now. And I'm going to tell you why we're using that. Okay, so we see something which is called this. Do you know what is this? It looks like, so right hand side is an object of the same class, like DynamicStringQueue. If I put a reference, that means that I'm taking the address, right? So this should be a pointer. And actually it is a pointer. So always when you define the class, there is a big pointer, not big actually, but the pointer which is pointing to the object I'm dealing with. And the name of that pointer is this. Basically, if I'm the class, it's pointing to me. Okay? Always, when you define a new class, member functions, etc., the borders of that class are pointed by a pointer which is called this, of that object. Okay? Now, why do I say this is not equal to right hand side? Sometimes I can do something like this. Can I say A is equal to A if A is integer? You can say it, it's not a mistake. And sometimes what you can do, you can say not Q1 is equal to Q, but you can say Q is equal to Q. If you do that, how does the operator equal work? Well, the operator equal, so if this is 1, 2, 3, and let's say here I have A, B, C, this is what the operator equal is doing. So it's taking right hand side. Now since we're dealing with the operator equal, this is my right hand side, RHS. So the values of this guy, let them be A, B, C. So I have A, B, and C. And I want myself to be equal to right hand side. So what I'm going to do is the following. First of all, as you see here, I'm going to call the clear function, which is going to delete all of those nodes. And then I'm going to call the createClone function, taking the right hand side as parameter, and I'm going to make the clones. I'm going to clone it, so I'm going to have something like this. A, then B, then C. Of course, as strings. Okay, front is pointing here, and rear is pointing over here. This is operator equal. I'm making myself be equal to right hand side. However, if I say I am equal to myself, okay, then I don't have this copy. And what should be the value in the end? What do you think? If I say this one is equal to myself, it should remain the same, right? But you see here that I'm calling the clear function. So if I clear it, and if I try to make a clone of myself, can I return the values there? No. That's why I'm using this part over here, the if clause. So if I don't want to be clone of myself, if I don't want to be equal to myself, then delete the elements of my queue and create clone of the copy in myself. Otherwise, I don't have to do anything. Because if I say I am equal to myself, there's no change. Okay? That's why. So this is the purpose why we do this. If I'm equal, I want to be equal to myself, I don't have to make any changes. Otherwise, I have to do it. Finally, what do you think? if I say q is equal to q or q1 is equal to q, did I make q1 equal to q? Pay attention, operator equal is a member function. That means that the left-hand side is the class, it's the object itself that is calling it. And the right-hand side is another copy. Okay? So, if I say operator equal, inside of this q, there's the class, the operator equal, and it's kind of a function. It's taking a parameter, which is of the same class, an object of the same class, and I want this one to be same as this one. So in the end, did I do what I wanted to do? So q1 is equal to q. Okay, so if I have a, b, c here, in the end, by creating clone, I have also a, b, c. Okay, so it's working, right? However, I have something like this, return this, start this. So this is referring to this object that I'm now using, okay? But if I say start this, so this is pointing to the object, it's a pointer. If I say start this, actually that means the object itself, right? So why I'm returning it again? Because only this part should be equal. I made q1 be equal to q. Why I'm returning a value now? What do you think? That's because of cascading purposes. What do we mean? Can I say q2, or this one q3, is equal to q1? Yes. So basically, if I'm using integers, I can say a is equal to b is equal to c, right? And here I can do the same. q3 is equal to q1 is equal to q, right? Yeah. However, which equality is going to be done first? This one or this one? The first one, this one, right? However, if this doesn't return any value, I'm saying q3 is equal to nothing, right? That's why I have to return it again for cascading purposes. Okay, so I can say q4 is equal to q3 is equal to, etc. Okay, did you get it? Okay, otherwise if I have only one equality, it's enough. With this piece of code, I already made the left-hand side, the calling object, be equal to right-hand side. But for cascading purposes, I have to create another copy. Okay, so this is it. So we saw operator equal. We have another operator, the last one, before we go with examples, which is operator smaller than. Let me find it. Operator smaller than. So what we are doing is we are taking an integer as value and we are comparing the q with a value. Basically, that value is an integer and I want to see whether the number of nodes that the q is pointing has now is smaller than that particular integer. So how do I do that? Well, I have a counter 0. Temp node goes to front, so this is my temp node. Temp node is pointing to front. Okay. And well, temp node is not. No. I have a counter here also. Okay. So the value of this counter is 0 initially. So if temp node is not now, I just increment the counter, meaning that I have one element here. So it's now 1. And I go temp node is equal to temp next. So I go to the next node. Is it null? No. So I'm making it 2 now. I go to the next element. Is this null? No. I'm making it 3. So I have 1, 2, 3 nodes. Temp node goes to the next one, which is null. Is this null? Yeah. Where counter is 3. In the end of this function, I'm checking whether the counter is smaller than the value that I've taken as parameter. If it's smaller, I say, yeah, it's the nodes that the queue has is smaller than the value. Otherwise, it's false. Okay. So basically, we can have something like this for comparison. Q3 is smaller than 5. Okay. If Q3 has 3 nodes, this is going to return true. So we saw 2 operators now: operator equal and operator smaller than. Okay. They're kind of a function, but not ordinary functions. And finally, we have something also important, it's the destructor. So we saw operator equal. Now we have the destructor. Now, what is the destructor? The constructor is called when I'm declaring a variable of a certain class, an object of a certain class. The destructor is called when I'm destroying it, deleting it. Okay, so let's see how it works. What do I do with the destructor? What do you think? When we don't need a class, an object of the class Q, what should I do? I should delete all of the elements, and this is it. All of the nodes of the queue. So let me find the destructor. Yeah, the destructor is basically calling the function clear, and clear was dequeuing all of the elements of the queue, one by one. And in order to know where am I, I'm just printing destructor is invoked. Okay? So this is it. Any question about this class? Okay. Here we had, again, copy constructor. And we saw the copy constructor can be deep and shallow. If you want a shallow copy constructor, this is commented out here. This is what you should do. Front is equal to copy front, Q front, and rear is equal to Q rear. Basically, you don't have to make, if it's ABC, you don't have to make it ABC again. You just say front is pointing to the first one, and rear is pointing to the last one of the object that I want to make copy of. If I want to make a deep copy, okay, then I'm creating clone. Okay, that means that I just point here, make a copy of this one, go to the next one, copy of that one, etc. Okay, because I told you, if front and rear are pointing to the same queue, and we have two objects of the same class pointing to the same nodes, if I make a change from one, the other can see it. We'll have problems. Okay? That's why we want to deal with deep copies, meaning creating clones, not with shallow, just pointing, just arranging the pointers. Furthermore, what do I call the copy constructor? Be it shallow or deep copy. I call it, as I told you, when I send a reference of a certain object, if I send a parameter which is not a reference, I call the copy constructor. Okay? 2, when I return a value, I always call it, because when I say return this one, I don't actually return it, but a copy of it. So remember here, with the operator equal, I'm returning this. But when I say star this, it's not actually this one. I'm returning a copy of it, and in the end, this guy is going to call the copy constructor. We'll see it in a while. Okay? And finally, whether I created a new object using a default constructor which doesn't have any parameters, parametric constructor, or copy constructor, in the end I should destroy it. And always I destroy it with the destructor. Furthermore, you should know this one. If you don't write a copy constructor, the compiler automatically writes it for you, and you can use it. However, the compiler writes a shallow copy, not a deep one. And if you write a shallow copy, it's going to have problems, as we saw it. That's why, if you are using something like this, which is a dynamically allocated memory, and you have pointers which points to those nodes, or the queues, then you should explicitly write copy constructor from scratch, from beginning. Because if you don't do it, the compiler will do it, and the compiler basically will do something like this. Front is equal to Q front, and rear is equal to Q rear. I'm just not going to create clone, as we saw, okay? Any questions till now? Yes?
This function is return parameter, as I see it.
Which one?
The ampersand sign. Not this one.
Operator equal?
Yes.
Yes, I told you. It's returning this.
Then shouldn't be returning the value itself, not.
Yes, because this is pointing to myself. Okay, so I explained it again. So if this is not, so sometimes I might say I am equal to myself. Let's say I'm the object that I want to create a copy of myself. So and there's a pointer with this pointing to me. If I say I am equal to this guy, then there's no problem. I'm going to clear my queue, make a clone of that guy's queue, and this is it. But sometimes I can say I'm equal to myself. And if I'm equal, I want to be equal to myself, let's see this operator equal, Should I change myself? No. That's why I say if this, which is pointing to me, is not equal to right-hand side. Right-hand side is the parameter that I take. But that can be also me. If I'm not equal to myself, then I should delete my queue and make a clone of your friend's queue. Okay? Otherwise, I shouldn't do any changes. Because again, if I clear my queue and I don't have my queue, can I make a clone of it? No, because I deleted it. That's why. Furthermore, why do I return myself again? Because I can do something like this. I'm equal to your friend, and someone else is equal to me. Just like here, A is equal to B is equal to C. Or in terms of Q, Q3 is equal to Q1 is equal to Q. Okay? Now, if I don't return anything, okay, then I will be equal to, let's say I'm Q1, then I will be equal to Q. But Q3 is going to be to something which is empty. That's why in the end of this function, I return a copy of myself so I can assign it to someone else for cascading purposes. What do I think cascading? What do I mean by cascading? Multiple equals, or maybe even other operators. As we're going to see, I can do something even like this. Q4 plus equal to Q3, etc. So this operator is going to return, equal is going to return again Q3, which is going to add something, which is going to be used as a parameter over here, etc. So let me explain it again. Can you do with integers something like this? A plus equal B equal to C. Yeah. Okay, and we are going to see it also with Q's. Okay, so if B equal to C doesn't return any value, then I'm saying A is equal to plus equal to something which does not exist, empty. And this is a mistake. Okay, that's why equal should return something. And also plus equal should return something, because I might say D is equal to this one. Okay? But of course, those are not integers. We are dealing with a dynamic string Q class. Any question? And remember, this is a pointer which is pointing to the object which is calling the function. Yes?
What was the purpose of Destructor? Because we just used the clear function.
Okay. So the Destructor is also using the clear function. Okay, but the clear function, you use it when you want. However, when the program is about to finish, or your scope, you are out of scope, the variable comes out of scope, it should be deleted. Okay, and how you should delete it? If you have dynamically allocated memories, well, you should explicitly delete it with dynamically, using the delete command. Okay, so it is calling basically the clear function. Okay, and why do we define clear? Because sometimes you want to make a copy of someone else, so you delete your queue and you make a copy. Okay, but in the end, when you should be destroyed, you always call the destructor. And if you don't write explicitly the destructor, you have memory leakages. Why? Because those nodes were created with a new command. Okay, that's why you should delete them with delete, and clear is doing exactly that stuff. Okay? So, constructors always are called when you create an object. Destructors always are called, it's a must, when an object is destroyed, when it's not in the memory anymore. Okay? Any question? Okay, do you want to take a break of 5 minutes before seeing the main CPP file? Or you want to continue? Okay. Who wants to stay? Who wants a break? Who wants a break? Okay, who doesn't want a break? Okay, we're going to continue. Okay, so let's see now the implementation of this class, how we use it in the corresponding CPP file. In the corresponding CPP files, we have two more operators. So here we saw member functions, which are operators, operator equal, and operator smaller than. We have another operator, which is operator plus, but that operator plus is, how do you call the functions which are not part of the class? We call them free functions, right? So let me delete this stuff. Don't need it. And I'm going to write the functions. So this is my operator plus. Now remember, operator equal, holding the operator equal, we have two parts. A is equal to B. But the left-hand side, the left, so the equality part, is the object itself. Because operator equal here is now member function. If operator plus was a member function, that we would have needed only one other parameter, which would have been the right-hand side, because the left-hand side is the object itself. But here operator plus, as you can see, is taking what? Two parameters, which are constant dynamic string queues. Constant references of dynamic string queues, okay, 1 and 2. Because it's a free function, it's not a member function, okay? That's why I have reference, let's say Q1, reference Q2. Okay. And what do we do over here? How do we define an operator plus? So basically what operator plus is doing, if this is Q1, let me write it as only Q1, like this. And if Q1 has something like this. So this is 1, 2, and 3. Okay, so this is my front, this is my rear. And Q2 has something like this. 4 and 5 only. So this is my Q2. Then operator plus is creating another queue. Let's call it Q3 or whatever, result maybe. This is my result. And result has something like this. 1, 2, 3, 4, 5. Basically, I'm adding elements of the first queue. I'm creating a result. Then I'm adding 1, 2, 3, and also 4, 5. So let's see how we're going to do that. Operator, so and I'm returning, the return value is another dynamic string queue, an object of the same class. So I define my result, which is, as you see. Then I have my first queue, and my first queue, I'm calling what? It's taking a parameter which is Q1. Okay, so basically I'm creating my first queue, and I'm using Copy Constructor to create it, and I take Q1 as a parameter. Basically my first queue is identical to Q1. So here I called it Q1, but basically the name of that guy should be, I'm going to use abbreviations. My first queue, MFQ. Okay, and it's equal to Q1. And I'm doing the same for my second queue, which is equal to Q2, that I take as parameter. So this is my second queue. Okay, and it's equal to Q2. As you can see it over here, I'm taking this as a parameter, function parameter, and here I'm creating another object of the same class, and I'm calling the Copy Constructor. Then I have a value in order to keep the value. So what I'm doing now, while my first queue is not empty, I'm dequeuing from the first queue. So basically result initially is empty. You see it, because I'm dynamic string queue result. I'm calling the default constructor, which makes front and null be null, okay? Because it's empty. And I'm creating the other two, my first queue, second queue, using the Copy Constructor. So what I'm doing now, I'm dequeuing from my first queue, from this one, and putting to the result. So basically I'm dequeuing there and putting here. Again, up until the end. 1, 2, 3. And I dequeue all of those guys. When I don't have what to dequeue, I do the same with the second queue. Okay. I dequeue from second queue and append it, enqueue it to the result. So 4 and 5. Okay. Of course, when I dequeue it, I don't have those anymore. Finally, what do? I return the result. Okay, I return this guy. Why do I do that? Because just as I'm doing Q1 plus Q2, then I might say Q3 is equal to Q1 plus Q2. Okay? So Q1 plus Q2 is going to return this result. And then I'm going to call operator equal as a member function, so I can make Q3 equal to Q1 plus Q2. Okay? Now see, operator plus, again, is not a member function. That's why it has two parameters, the right-hand side and the left-hand side. We call it Q1 and Q2. But operator equal is a member function, is a member operator. That's why, if you see, if you remember, it was taking only one parameter. And that was the right-hand side. So operator equal here, it was taking only one parameter, the right-hand side. Why? So operator equal is taking only this part because the left side is myself. Because operator equal is a member function, so the left side is always myself. Okay, but when I say myself, it's the object that is calling that function. Okay, so this is operator plus. We have another operator, plus equal. So what do we do with plus equal? Again, we are taking the left-hand side and the right-hand side. The right-hand side, so since plus equal is not a member function, the plus equal is a free function. So that's why we have also two parameters, the left-hand side and the right-hand side. Okay, they are both, okay, so my first Q is here, my second Q, let me not delete them. I'll tell you why. Okay, so operator plus equal was taking those two values, and what I'm doing, you see, the left-hand side is not constant. Why is it not constant? Because I'm going to change it. Basically, what plus equal is doing is taking element from the right-hand side and appending to the left-hand side. Okay? So, if this is, I'll delete them and I'll explain you what's going on later on, and I'll run the code. So if this is my left-hand side, and I have nodes like 1 and 2, okay, front and rear, and this is my right-hand side, and in my right-hand side I have nodes, let's say 3 and 4. What plus equal is doing, I'm taking from the right-hand side, I'm putting to the left-hand side, and I'm changing the left-hand side. Okay? So the rear is pointing over here. This is what I'm doing. Okay? So how am I going to do that? Well, I'm creating a new right-hand side queue, which is an object, and you're calling the copy constructor. Okay. Then, while the right-hand side queue is not empty, I'm dequeuing from it, and I'm queuing to the left-hand side. Basically, I'm changing the left-hand side. And finally, for cascading purposes, I'm returning the left-hand side. Again, what do I mean by cascading purposes? You saw like Q3, you can do it is equal to Q1 plus Q2. But I can say Q4 plus equal to this one. And maybe Q5 is equal to this one. This is cascading purpose. So here I call the function plus, and it's returning a value. What I return will be the left-hand side of operator equal. And this is going to return something, and this will be the right-hand side of operator plus equal. And this is going to return something, and this will be the right-hand side of operator equal again. Okay? That's why this is called cascading purposes. I'm returning something which is used for another function, and not left-hand side. Always is for the right-hand side. Okay? So this is it. And remember, when I return a value, I'm always returning it calling the copy constructor. So I'm returning not the left-hand side itself. I return usually, unless it's a reference over here, it's a reference. If it's not a reference, the return value, I'm returning a copy of it. Okay? So here, the return value is a constant reference, means that I shouldn't change the left-hand side. Okay? After I return it. But inside of the function, it's not a constant reference, so that means inside I'm changing it, because I'm appending some values, I'm enqueuing some nodes, but when I return it, I'm not creating a copy, it's a reference. But here, it's not a reference, as you see, dynamic string in operator plus. It's normal value, so that's why I'm calling the copy constructor when I return the result. Okay, and we will see it when we run the code. Finally, we have the print function. I'm taking the queue, I'm taking a copy of the queue, as you see, it's not a reference. And if it's in the debug mode, I'm just printing the queue. While the queue is not empty, I'm dequeuing the value and printing it. And this is it. Okay, so when I'm calling the function print, actually I'm sending a copy of the queue that I want to print, not the original queue. Okay, finally, we are at the main function, and let's see what do we have. Let me run the code. Let's see the output, and let's see how did we get that output. Let me learn the font also. So font is 28. Is it okay? Okay, now let's see how did I get this output. Okay. So, I'm creating two queues. I'm in the beginning now. I'm creating two queues. 3 queues, I'm sorry. And I'm calling the default constructor. This is the value. To the first queue, I'm adding Ali, Veli, Kemal. When I add that, you remember from the enqueue function, I just said that Ali enqueued, Veli enqueued, Kemal enqueued. Then I just say Q1 and I print the queue. But when I print the queue, you see that I'm sending the queue as what? I'm sending the copy of it. And when I send the copy of it, I'm calling the copy constructor. So Q1, after that, after Q1 is printed, I'm just saying copy constructor is invoked because I'm sending a copy of it. Okay. Now I'm inside of the print function, so I'm saying printing the queue because I'm running it in debug mode. While it's not empty, I'm dequeuing the queue and printing the copy. So Ali dequeued and I'm printing Ali. Then Veli dequeued and I'm printing Veli. Kemal dequeued and printing Kemal. And in the end, I'm calling the destructor. Destructor that I'm calling is of this my queue. Okay? You asked me what is a destructor? Well, when an object shouldn't be in the memory anymore, which is like the function is going to finish, so everything that is related to the function is going to be deleted, including this guy, which is the copy of Q, and here I call this my Q. So it's going to be destroyed, that's why the destructor is invoked. Okay. Now we're going with the second queue. And in the second queue, I'm queuing Delia, Ayşe, Aslı, and I print it. So I print now Q2. Again, I want to print the queue, so I'm sending a copy of Q2. That's why I say copy constructor is involved. And then I go to the print function here, and I print the queue. So I print Delia, dequeued. So when I dequeue it, I just say Delia dequeued, and then I print Delia. Ayşe dequeued, Ayşe Aslı till the end. And finally, destructor is involved of this guy over here, which I created with copy constructor. Okay, now I print, after this is finished, I print those stars. So I print the stars right now. Now, comes the interesting part. I'm calling the function Q, so result is equal to Q plus Q2. Okay? Plus, so what I'm going to do first, of course, I'm going to execute Q plus Q2 first, okay? And then the result, I'm going to return something and assign the result. But when I call the operator plus, what I'm doing, sorry, you see I'm copy constructor. What I'm doing with the operator plus, you see I'm taking them as references, but inside of them, I'm calling the copy constructor twice to create my first queue and my second queue, okay, which are equal to Q1 and Q2. That's why I call two copy constructors. Okay. Now, I go with the first queue. While it's not empty, I'm dequeuing from it and requeuing to the result. So my first queue, I dequeue from that guy and enqueue to the result. So Ali is dequeued and enqueued Ali, Veli, Kemal. I do the same with the second queue. So I dequeue what? Delia, Ayşe, Aslı. Dequeue and enqueue them. Okay. Finally, I return the result. But when I return the result, what I told you, I'm returning a copy of it, so copy constructor is invoked. Invoked, right? Okay, when I return the result, where do I go now? I go to the function, but I'm calling two destructors. Which are those destructors? Well, the destructors that I'm calling are for this one, for this one, and then another destructor is involved for the result. Okay? So the result, if you remember, had Ali, Veli, Dedi, Aisha, Kemal, all of them. And I do that. And another destructor is called for the value that, so I have here three objects, right? Result, my first queue, my second queue. My first queue, my second queue are empty, that's why I don't dequeue something, okay? But result is equal to all of those guys, so here is my result. So this is my Q1, my first queue, this is my second queue. They were empty. This is for the result. This is for the result, and this is for what the result returned using the copy constructor. Okay? Now, I go to the function, to this function over here. I just used plus Q plus Q2, right? Now the result that I created with copy constructor will be my right-hand side, and I'll say result is equal to what those guys returned. Okay? And I'm going now with the operator equal, and let's see what was operator equal doing. Well, I don't create anything here. I just create the clone, and I say return this. But when I return this, I return it as a reference, so I don't make any copy. Otherwise, if this wasn't a constant reference, I would have created a copy. Okay? Fine. So, now result is equal to what those two guys are. And then I print result is equal to Q plus Q2 is done, plus operator example. Then I print the result. When I print the result, I call the print function calling by sending a copy of the result. So I'm doing it with the copy constructor. And then in the result, if you remember, I'm printing the queue, so Ali, Beli, and dequeuing and printing, dequeuing and printing. And finally, since I send a copy of this result over here, I should delete it using the destructor. Okay? Now I'm printing those stars. Now I'm using the function q plus equal to q2. Let's see what was it doing. And I'm calling a constructor. Why? Well, q plus equal. Q plus equal was taking references, but inside I'm creating right-hand side q, and this is the copy constructor that I'm invoking. Then what I'm doing, while the right-hand side is not empty, I'm dequeuing, so I'm dequeuing, and then enqueuing. Okay. Finally, this right-hand side is going to be deleted. That's why I say destructor is invoked. But left-hand side is not going to create a copy. Why? Because I'm returning a constant reference. Okay? That's why I'm not creating a copy. Now, where I'm going to q plus equal q2 is done. Okay? Plus equal operator example. I'm printing the q1. And the q1 now is empty from before. So I just create a copy. No, it's not empty. I'm sorry. Q1 is not empty. So I create a copy of Q1. I'm printing the Q, and in the end the copy is destroyed. Then I'm printing Q2. I send a copy of Q2. I print the Q, and the copy of Q2 is destroyed by the destructor. Now I have those stars. Okay. Now I have plus equal to Q2. This is the first call. That's why I'm telling you I need cascading purposes. Because Q2 plus equal to Q is going to return something, and that will be a parameter for this next plus equal function. Okay? So you remember in the plus equal function, I have only one copy constructor, which is called. So I send those guys as references, so I don't call the copy constructor. But here inside, for the right-hand side Q, as I mentioned before, I'm creating the right-hand side queue using the copy constructor. Basically, it's a copy of right-hand side. Okay, that's why I invoke the copy constructor. And if you remember, this is what I'm doing. I'm dequeue equal to the right hand side and adding it to the left hand side. Okay? And finally, I'm destroying the right hand side queue. Okay? This is it. So let's go back to where we left, and we left here. When this is done, I return something, and I assign, and this will be a parameter for the next plus equal function. That's why, again, I send the copy constructor, again, there enqueue, dequeue, blah, blah, blah. And finally, for the copy constructor, which was right inside queue, inside of the plus equal function, I call it destructor. Finally, I print this guy, q plus equal is done, and this is the plus equal operator example. I print the q1, and I call the copy constructor because I'm sending a copy of it. But q1 is okay. I print the q1. Then I print the q2, and I'm sending the copy constructor. And in the end, that object, the q2, the copy of q2 is destroyed. Finally, I'm printing those stars. I say q2 is equal to q. And q2, if your operator equal, was a member function. And as you see here, I don't make any copy constructors here because I take a reference, I return a reference, so I don't do any copy constructor calls with q2 equal. I just say q2 is equal to q. And what I'm doing here, you remember, first of all, I clear the calling function, and then I create a clone. And when I clear, you remember the clear function was calling the dequeue function. So here we are with the dequeuing, dequeue. And then, if you remember, I'm assigning q1 to q2. So basically I create clone, and create clone was adding them one by one. I do not calling the enqueue function. When I'm finished, I just print that q2 is equal to q1 is done. Okay. So q1 is, I'm calling the copy constructor to print this one, and I'm printing q. Okay. So I'm printing the q. In the end, I destroy the object that I sent, the copy of q. Again, I print q2 now, and I send q2 as an object, as a copy. I print q2, and then I destroy the copy of q2. Then I have the stars. Again, please enter value to compare. We are here right now. The value I want to add is, let's say, 5. Do we see it? Okay, I'm adding 5. Okay, system pause is not. Okay, should have been system pause. Never mind. We can do it again. Not the whole stuff, only. So, system pause should have been. Okay. So basically, let me just show you the last part when I'm comparing this one. And we are finished. Okay, so again, enter value to compare. I'm entering 5. So after I'm adding 5, I'm basically calling the, here, if q2 is smaller than 5, I'm calling the operator greater than. So it was this operator over here, operator smaller than, I'm sorry. Should be downwards, I suppose. Okay, this one. And if you see here, I don't create any copy constructor or whatever for the class. So I'll just, if q2 is smaller than the value, which the number of nodes is smaller than the value, I'm printing number of elements inside the queue is smaller than. Otherwise, I'm printing is greater than. So number of elements inside the queue is greater than 5, because I have, I think, 6. And this is the end. If you're not sure how this is done, so this is the last minute that I'm going to take to you, this is what you should do. Just put breakpoint, go on, and maybe I should do something like this, so I have both of them displayed. Okay, so maybe like this. Okay, this is from the previous one. Let me close it. So right now I'm here. I can use F10 and F11, but if you want to see what's going on, I just press F10. Then if you want to see Q2, basically Q2 is calling the default constructor. Just can say debug, step into, and you see this is the default constructor. Okay? You can go debug, step over, or F10, let me use F10, 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 F10. I'm done with this one, then I'm done with this one. Now I'm using enqueue, so I'm printing this one, this one, this one. Now if you want to see, I'm going to the print one, okay? Now let's see inside what I'm going to do. First of all, see what I'm calling the print function, but inside, I go and step into, I'm calling the copy constructor, okay? Why? Because print function is sending a copy, that's why. So debug, F10, step over. I'm calling the createClone, okay, step over. Since this is debug mode, I'm printing copy constructor is invoked. So step over, okay. And I go outside now. I go actually at the print function now. So here, and print function I should have entered again, step enter, but when I call the print function, this is what is done. Actually, we can do it. We can see it again right now. So debug, step over. I'm enqueuing some values here. Step over. Now we're going to see again how it works. Okay, step over. So I'm printing now Q2. Now I'm going to say step into the function. Again, I'm creating the clone. I'm sending a copy of the parameter. Step over. Debug. Step over. Debug. So I'm creating the copy of the parameter now. And the copy is created. So I'm at the print function now. Now I go at the print function. I stay step into. I go to the print function. Now let me go step over. I go, or F10 to be faster. I'm printing the queue. While my queue is not empty, I'm just printing them. Taking the values and printing them one by one. Okay. Now I'm calling, you see when the function was finished, I called the Destructor. If I have pressed step into, we would have seen the Destructor. So this is what you can do at your home. If you're not sure which is called, why it's called, one way is to use breakpoints. Another way is just in the constructors, destructors, copy constructors. Right, you are the copy constructor now. You're calling the destructor. You're calling this one, so you should know what you're doing. Okay. To conclude, we have deep copies and shallow copies. When deep copy constructors and shallow copy constructors. Okay. If you don't write explicitly the compiler is going, the copy constructor, the compiler is going to write it, and the compiler always writes the shallow one. But sometimes you need the deep copy, as we saw here, so you should write it, the deep copy. When you send a parameter, which is not a reference, you call the copy constructor. When you return a value, which is not a reference, you call the copy constructor. You always return a copy, and you always send as a parameter to the function a copy, not the original one. Of course, if you are not dealing with references. And you have operators. Operators can be member functions or free members. If they are member functions, then the class, the object inside, is the left-hand side of the operator. If it's a member, if it's a free function, then you should have two operators, the right-hand side, two operands, the right-hand side and the left-hand side. So this is it. Let's take a break of 5 minutes and we're going to explain the homework. Okay.